Welcome back to the third lecture of vector algebra. In this video, we'll try to derive the vector formula for section formula, and also we'll try to utilize that and solve some problems along with solving some unit vector problems. Now, section formula, you have already learned this in your 10th and 11th standard where you have utilized it as an analytical formula. Here, we will try to utilize that as a vector form. Let us try to understand the section formula in vector form with the help of a line AB. Now we have AB, which is a line which is going to be divided into two parts by a third point x. Now this x divides the line into two parts. It could be either 1:1 ratio or it could be of any ratio. So let us take that as m and n. So ax is equal to m and bx is equal to n. So if we divide ax by bx, which is in terms of magnitude, that should be equal to m by n. Now let us take a point O, which is going to act as the reference point or the origin. From O connecting B will be act as the OB vector or the position vector, which is B vector. OA is the position vector of A, which can be taken as A vector, and OX is the position vector of the required point, which can be taken as X vector. Now if we mark the direction of the vectors, xb vector, since we are going to talk about the magnitude, bx or xb is fine. OA vector is marked, and ax vector, OB vector, and OX vector. Now by using the vector formula to find AB vector in terms of the position vector, here we need AS vector. So we will take this triangle where we will apply the vector form. So we know that AS vector is equal to OX vector minus OA vector. So this is how we could find the vector using position vectors. OAS vector here is X vector minus OA vector is A vector. The same way, XB vector can be found using the formula OB vector minus OX vector. Now OB vector is B vector and OX vector is X vector again. So it is B vector minus X vector. Now taking this and substituting it in the formula AX by BX, instead of BX we can take XB because we are going to take the magnitude. So AX vector by XB vector in terms of magnitude is equal to m by n, because AX vector, the magnitude of AX is m and the magnitude of BX or XB is n. Now substituting the value of AX vector and XB vector and simplifying it, we'll get the formula. So AX vector is X vector minus A vector is equal to m into, if here it is n, xb vector goes to the other side as the numerator. So xb vector is b vector minus x vector. So this is the vector form where you could use it to find the section formula. So n vector into, instead of x I am writing it as r vector minus a vector is equal to m into b minus r vector. Now our objective is to find the position vector r vector. So we are finding the coordinate. Now if you remember from the previous cases, you would have found the x comma y of the section which divides the line in the ratio m is to n. So here we are trying to find the ratio, that is the vector formula r vector. So nr vector minus na vector is equal to mb vector minus mr vector. Rearranging this as mr vector plus nr vector is equal to mb vector plus na vector. So taking r commonly out, r vector is equal to mb vector plus na vector divided by m plus n, where m and n are the ratio. Now if you look here, when we take m, we have to take the other side vector. So it is the opposite that you have to take. You would have remember m into x2 plus n into x1. The same way here, when I take m, I have to take the b vector, and when I take n, I have to take the other side, that is your a vector. So m, n. So taking it here, right, we have mb vector plus na vector is equal to m plus n vector. Now we'll try to do the same thing for a point which is dividing the line when it is outside. Now the point that we have taken in the previous case was in between A and B. Now we'll have a condition where A and B are the points and there is a line between A and B. If there is a point R which is outside the line AB, and how that divides the line AB in the ratio. That's the objective here. So A R can be taken as A R equal to M, and B R can be taken as N. So this is the ratio M is to N. Now using the same approach that we have used in the previous case, this also can be derived. For example, we'll have the position vector OR vector, which is the required position vector. Then we'll also have OB vector and OA vector. So OB vector is given by B vector and OA vector is given by A vector. Now using the vector approach, for example, AR vector is equal to OR vector minus OA vector, which is R vector minus A vector. Then BR vector is equal to OR vector minus OB vector, which is again R vector minus B vector. Now this is what we have for AR and BR. Now AR vector by BR vector is also equal to M by N. So their magnitude, we are comparing the magnitude. So R vector minus A vector divided by R vector minus B vector equal to M by N. Rearranging R vector minus A vector into N equal to M into R vector minus B vector. Simplifying this, we'll end up with the equation of R vector when the point lies externally. So R vector is equal to MB vector minus NA vector by M minus N. So you can compare that in the previous condition we had plus, whereas here we have negative sign. So this only difference here is the negative sign, the other approach remains the same. When you take M, you have to take the B vector. When you take N, you have to take the A vector. So this is the simplest approach. So we have the formula for R vector when the point is in between A and B and outside A and B. Try to do this sum. Find the unit vector in the direction of PQ, where P and Q are the points. So we have two conditions here. So we'll do one sum and the other you can try to do it. So this is the unit vector type. So we have already discussed what is a unit vector. A vector with only the direction and the magnitude is 1. If you cannot have it 0, then it will be multiplied, you will get 0. So you would have learned multiplicative identity, which is 1. So here we will be having PQ cap, which is going to be equal to PQ vector by modulus of PQ, because we are going to divide it by the magnitude, so that we will end up only with the direction. So here we don't have PQ, rather P and Q are separately given. So we have to find a PQ vector. So the first point we take it as the P vector, that is your position vector of P, and the second point can be taken as the position vector of Q. So OP vector is equal to I plus J plus 4K, and OQ vector can be written as 5I plus 3J plus 2K. So I, J, K are the directions of X, Y and Z axis. So now we need PQ vector. We have already discussed the formula. PQ vector is equal to OQ vector minus OP vector. So the position vector we are going to subtract. So OQ vector is technically 5I plus 3J plus 2K here. So we write that minus, right, you should be careful when you take the minus. So this bracket is very important. So 1I plus J plus 4K. So subtracting this, we will end up with the PQ vector, which is 5I minus I. Only the same components are subtracted, like terms. You have learned this in your algebraic identities. So 3J minus J plus 2K minus 4K. So 5I minus I will end up with 4I. Then 3J minus J is 2J. And 2K minus 4K is minus 2K. So this is your PQ vector. Now, this vector technically has a magnitude and direction. I want the direction alone. So, my PQ cap is equal to PQ vector by modulus of PQ vector, where modulus is just the square and addition of all the components, coefficients, and taking the square root. So 4 square plus 2 square plus minus 2 the whole square. You should be careful with the minus here. 16 plus 4 plus 4, that is root of 24. So my magnitude of PQ is root 24. That's it. So my PQ cap is equal to 4i plus 2j minus 2k divided by root of 24. So taking the components separately, you can write 4 by root 24i plus 2 by root 24j minus 2 by root 24k. So this is the required answer for the given condition. This could be further simplified because root 24 can be written as root of 4 into 6. We don't have exact root for root 6, but we have for 4, so 2 root 6. Now further simplifying the condition, you'll have 2 by root 6 because 2 and 2 will cancel, 1 by root 6 and minus 1 by root 6. So this is the answer for the given condition. The same way you could try doing the next sum, that is the second subdivision, where it is 1, 2, 3 is your OP vector and 4, 5, 6 is your OQ vector. So by doing this, you'll get confidence to do the sum. Now we'll go ahead with the next sum. For a given vector A and B, find the unit vector in the direction of A plus B vector. So we have to find A plus B first and then we have to find the unit vector. So adding two vectors is just adding the components. We have already discussed, right? You have to add the like terms. That is, I and I will get added together, j and j will get added together, and k and k. So you have to consider the sign when you are adding it. So 2i and minus I here. So that will end up as 2i minus I, that is I. So this way you can find a plus b vector and solve the sum. The next question, find the vector in the direction of given vector which has a magnitude 8 units. So we have to find a vector with both magnitude and direction. The magnitude is already given, it is 8 units, whereas my vector should be directed in the direction of the 5i minus j and 2k. So that is the objective here. So my magnitude should be 8 and that should be directed in the direction of the given vector. So technically, I need the direction of the given vector, and on that direction I should have a magnitude of 8. So our objective here will be first finding out the direction of the given vector. Once you have the direction, in the same direction you should have a magnitude of 8. Now unit vector, as we have discussed, it is a magnitude 1. So once I get the magnitude 1, if I multiply that with 8, I will have a magnitude of 8. It's that simple. So we have to find the direction of this particular vector a cap, if that is a vector. So that is a vector by modulus of a vector. So we have a vector directly. So finding modulus of a vector, we'll end up with 5 square, which is 25, minus 1 the whole square, which is 1, and 4. So that is root 30. You could write this as root of 5 into 6. So we cannot take anything out from the square root. So we'll keep it as root 30. So required vector should be 8 into a cap, that is 8 times the direction. So 5i minus 2j, sorry, minus j plus 2k divided by root of 30. So this is the required answer. You could further simplify, maybe taking this root 30 outside and write, or you can bring it this 8 inside and write. Now show that the vectors are collinear. So we have two vectors. We are going to show that these are collinear. Collinear vectors are two vectors which are parallel. Right? That's what we have discussed in the initial stages. So when two vectors are parallel, they'll have same direction. Only thing is they may have a different magnitude, but the direction will be same. Then only they are called as a collinear vector. So our objective here is to prove it as a parallel vector. So the first vector is 2i minus 3j plus 4k. The second vector is minus 4i plus 6j minus 8k. So I take minus 2 commonly out and I'll end up with the same a vector. So technically I'm proving here my b vector is equal to minus 2 into a vector, where minus 2 is a scalar. So I can take it as lambda to denote. So whenever my one vector is a scalar into the other vector, then obviously my second vector is parallel to my first vector because they have the same direction, only the magnitude is different. So therefore a vector and b vector are collinear. Now the next sum, find the position vector of R which divides the line joining 2 points. This is why we are going to use the section formula. So we have two vectors P vector and Q vector, the position vectors are given, and we have to divide this into ratio 2 is to 1 by having a position vector R. So my OQ vector and OP vector, those are the position vector, and we have to divide it into the ratio 2 is to 1, condition 1 internally and condition 2 externally. So let us try to do it for condition 1, which is internally. So it is 2 is to 1. So I am drawing a point R vector, and the second condition is externally. So P, Q and R, where my R is outside, and this is how the ratio will be 2 is to 1. So we'll try to do it for the first condition, which is the internally. So the formula is R vector is equal to M into B vector plus N into A vector plus M plus N, and M is the 2 and 1 is the value of N. Then technically 2 into OQ vector should be taken. You should be careful here. We have discussed this. So when I take N, I should take OP, and when I take M, I should take OQ, because M is closer to P and N is closer to Q. I should take the ulta. So 2 into my point is OQ vector, that is minus I plus j plus k vector, and plus 1 into, that is my n into I plus 2j plus minus k vector divided by 2 plus 1, which is 3. So simplifying this, so 2 into minus I plus j plus k and 1 into I plus 2j minus k by 3 will get the position vector R for the first condition, which is the line divides it into the internally. Now the same way, R vector equal to MB minus NA divided by M minus N when the position of R is external to the point PQ. So you could utilize this formula to find the value of R vector. You could also write like this, multiplying minus on both the side, numerator and denominator. You will have this formula where you can directly use it to find. Again, notice that N and A or the ulta. When n I take n, the a should be the other side vector. Using this, you can find the position vector. Thank you. Happy learning.